T-intervals for the true population mean mu will involve the famous T-table. This T-table will be attached to your test. Before I discuss the properties of the famous student T-distribution, I will tell you that for a T-interval for the mean, the only degrees of confidence that I am allowed to ask you according to the table would be 50%, 80%, 90%, 95%, 98%, and 99%. Therefore, if it is a T-interval for the mean, I cannot ask you for a 94, a 92, a 97. It has to be one of these above. That is because I create the test as if I only have the T-table and not the calculator. Obviously, with the calculator, when you go to Stat and Test, these T-intervals will be number 8. When you press Enter, obviously here for C-level, I can put in 94% or 92%. But because the table, the T-table, is restricted to certain degrees of confidence, I cannot ask you for a 92% T interval for the mean. I can ask you for a 92% Z interval for the mean, but not a 92% T interval, in all fairness, because of the table. And I use the table to create the test. So these are the only possibilities above. Now, the other thing I wish for you to know is all of these values that you see inside here are the T values, the critical values that we are going to need to calculate these intervals. Notice how they're given to 3 places. So Z scores are given to 2 places, but T scores or T values are given to 3 decimal places. Now, you notice it says DF, which means actually degrees of freedom. But degrees of freedom will be the sample size minus 1. Sample size minus 1. So if our sample size happens to be 10, we will go to 9 degrees of freedom. If our sample size is 10, N is 10, go to row 9. If our confidence level is 90%, go to the column that says 90%. Where your 2 fingers meet, 1.833 is going to be your critical value, T sub C. It's going to be that simple. If you know your sample size and you know your degree of confidence in a word problem, you can find your critical value, T sub C. The trick is, do not go to your sample size row, but go to degrees of freedom, sample size minus 1. So if sample size is 10, go to row 9. And again, all of these degrees of confidence. For now, for Chapter 7, you could actually block out or cross out 1 tail alpha and 2 tail alpha. We will not use those 2 rows on this test 3, Chapter 7. We will use it when we arrive at hypothesis testing. So, let me teach you the properties of the student T distribution. Again, we're going to have certain rounding rules, and I'll refer to those rounding rules as we approach those rounding rules. And the 2 problems that we're going to do that are T intervals for the mean are these problems 1 and 2 here. Before we do those 2 problems, I do need to teach you the properties of the student T distribution. Properties of the student T. Now, first of all, it's a T interval for the mean when sigma is unknown and n is less than 30. Both conditions have to be satisfied. N less than 30 means the sample size is small. The student T distribution shares some characteristics of the normal distribution and differs from it in others. The t-distribution is similar to the standard normal distribution or the z-distribution in the following ways. They are both bell-shaped. They are both symmetrical about the mean. For both of them, the mean equals the median equals the mode, and they equal 0. They are located at the center of the distribution. And for both the z-axis and the t-axis, the curve never touches the axis. Those are the four they have in common, the standard normal in z and the student t-distribution. The student t-distribution differs from the z-distribution in the following ways. Remember with the z-distribution that the standard deviation was exactly equal to 1? Well, with the t-distribution, the variance is greater than 1, strictly greater than 1. The t-distribution is not just one curve. It is a family of curves based upon degrees of freedom. df means n minus 1, which relates to sample size. And letter C is my favorite. It's calculus based. As your sample size, n, increases without bound, which means approaches positive infinity, it grows larger and larger and larger. 10, 100, 1,000, 10,000, 100,000, a million. The student t-distribution approaches and grows closer to the standard normal distribution, the z-distribution. So as sample size increases without bound, t becomes z. And so it becomes normal, more and more normal. The student t-distribution becomes more and more normal as sample size increases without bound. So these are the three ways they differ from each other. A normal distribution versus a student t-distribution. Here is a great pic of what I was speaking about. This is a student t-distribution that is a family of curves. We have in the solid here the z-curve. And then we have, and it's hard to see, but I have two dotted curves here. A t-curve for degrees of freedom of 20, which means its sample size was 21, and a t-curve for degrees of freedom of 5, which means its sample size was 6. What happens is as your sample size increases from size 6 to size 21, then you see that these dotted curves approach the solid curve, which is a z-curve, a standard normal curve. And the mean of all of those would be 0. So as sample size increases, degrees of freedom is obviously going to also increase. So from 6 to 21, degrees of freedom goes from 5 to 20. And therefore, these t-curves approach the z-curve. So let's start problem number 1. And see why it is a t and not a z. Consider the student t-distribution. Find the critical value t sub c for a sample size of 18 when a 99% confidence interval is needed. This is not even a complete problem. What this question is asking is find t sub c if sample size is equal to 18, and we want to calculate a 99% confidence interval for the true mean. It's very simple. You go to your t-table, and you would have to go to row degrees of freedom 17. So go to row 17 and go to column 99%. Where your two fingers meet, that's going to be your t sub c. row 17, column 99%. Two fingers will meet at 2.898. T sub C, critical value, is 2.898. 99% degree of confidence. And then your sample size minus 1, 18 minus 1 is 17, 2.898. So that's question number 1. Question number 2. The average daily intake of calories for young women is 1,667. To see if this is valid for all female nurses, take a sample of 15 nurses. It was recorded that their average caloric intake was 1,593. The standard deviation of the sample was 36 calories. Find the 90% confidence interval for the true population mean. Does the population mean of 1,667 calories for all young women fall in this confidence interval? Explain. This problem is a little bit different. They actually give us mu, the true population mean. Remember, we don't necessarily have to know it. But in this problem, they tell us the average caloric intake for all women is 1,667. That is your mu. To see if this is valid, they take a sample of 15 female nurses. It was recorded that the sample of 15, X bar, had an average caloric intake of 1,593. That's X bar. The standard deviation of the sample, S, was 36. So this is S, not sigma. Find the 90% confidence interval for the true population mean. So let's write this down. The true population mean is 1,667 calories. And I'll tell you that this is for all women. Remember, keyword all implies population. And this is a rare fact that we even know the true population mean. To see if this is valid, they take a sample of 15 female nurses and they find that their average caloric intake was 1,593 calories. The standard deviation of the sample, S, was 36 calories. Find the 90% confidence interval for the true mean. The next step is to decide, is it a Z or T? Now this is a T, but let's write it down. A Z interval for the mean or a T interval for the mean. Sigma is known, or N is at least 30. Sigma is unknown, and at the very same time, N is less than 30. I think that you can see that N is 15, so N is less than 30. They say sample standard deviation, therefore sigma is unknown. Both conditions are satisfied, and I do have to satisfy both this time to make it a T and not a Z. Once you verify that it's a T and not a Z, you write down X bar minus T sub C, S over the square root of N. X bar plus T sub C, S over the square root of N. We do have to find our T sub C. So we will go to column 90%, and we will go to the row degrees of freedom 14. Row 14, column 90%. Where your two fingers meet, that will be your critical value. Row 15, column 90. Your two fingers meet, and I believe I said row 15, row 14. The sample size was 15, so go to row 14. and then column 90%. 1.761. 1.761 T sub C. And just be aware, especially TI-84 calculator people, there will be a question on the test that asks you for just the critical value for a problem like this. So you're just to give me the critical value. I don't give you an indication if it's a Z sub C or a T sub C. I give you the background information, and then I ask for critical value in general. And then here are the choices. A, 1.761, B, 1.65, C, 1.753, and D, 1.96. Obviously, you'd go with A. Those of you that incorrectly label this as a Z interval for the mean, you're going to say that it's 1.65, so you'll be wrong. Those of you that go to row 15 and column 90%, you will also give me the wrong answer of 1.753. Wrong answer. Correct answer is 1.761. Go to row 14. Be very careful with that. But I really feel that most people that heavily rely on the TI-84, they may mistakenly go with letter B, 1.65. But this is not a Z interval, 90% Z. It's a 90% T. So you have to use the T table. Let's plug in. This is going to be 1593 minus 1.761, 36 over the square root of 15. 1593 plus 1.761, 36 over the square root of 15. 1593 minus E, and 1593 plus E. E, go to Stat, arrow over to Test, and down to number 8. Enter. T interval. Again, it can be a raw data problem where they give you all the raw data of the sample and you put it in a column, but it's not. If it is, you press Enter. But it's not. So let it blink on Stats and press Enter. The sample mean is 1593. Sample standard deviation, S sub X, is 36 calories. Sample size is 15 female nurses, and the degree of confidence is 90%, and then calculate. $1576.6 to $1609.4. I will write both of those values down. And, excuse me, I believe I kind of jumped to the conclusion of showing you the calculator before I finished how to show you how to do it by hand. I apologize. This is the calculator result if you go to Stat Test number 8, and I'll write this down in just a moment. But the E, 1.761 times 36 divided by the square root of 15. E is 16.3688. 16.3688. Let me finish this by hand. Subtract from 1593. $1576.6312. Add to 1593. $1609.3688. And now we round. We round the lower and the upper to the same place as the given sample mean, which happened to be a whole number of 1593. So this one rounds to 1577, and this one rounds to 1609. Your confidence interval width, 1609 minus 1577, is a difference of 32. On the test, I will ask you for this problem just to give me the critical value, just to give me E, to give me the final answer rounded accurately, and to give the confidence interval width. Those of you that unfortunately give the wrong critical value of 1.65 because you say it's a Z interval, watch this. You will be telling me the wrong E because you're using the wrong critical value of 1.65. You're telling me that it's a Z interval, but it was a T. The critical value was 1.761. But you said it's Z and you used 1.65. So I will have ABCD, one of the wrong answer choices, 15.3370 as a possibility. So beware on the test when I ask you for E, 16.3688 is the correct answer, but I'm also going to have the 15.3370. And this is meant to catch people that incorrectly call it a Z interval, and they're using the critical value 1.65 for a 90% confidence interval. So be very careful there when I ask you for E separately as a separate question. Going back to the calculator, stat, test, number 8. I already have the information in, so I'm just going to press calculate once again. It agrees with what you have by hand, 1577 to 1609 if you round accurately to a whole number. That's basically it for T intervals. They're not that complicated. The last two problems on the sheet actually are review problems. The first one is a Z interval and the second one is a T, and I do want to do both of those. The average weight of 60 randomly selected compact automobiles is 2,627 pounds with a sample standard deviation of 400 pounds. Find the 99% confidence interval for the true mean weight. The average weight of 60 randomly selected compact automobiles. So N is 60. So this is the review, and this is number 1. The average weight of 60 selected compact automobiles is 2627. So that's your X bar, the average weight of the sample of 60. It also says with a sample standard deviation of 400 pounds. So that's your S. S is given, not sigma. They said sample standard deviation. Sample mean, sample standard deviation, sample size. Find the 99% confidence interval for the true mean weight. The true mean weight, and that is mu. This is a Z interval. Sigma is known, or N is at least 30. Sigma is not known, but that is absolutely okay because, check, my sample size is 60. I only have to satisfy that one condition. So sigma is unknown. They give us S, sample standard deviation. Only one condition is satisfied, and that's all I need for a z. So x bar minus z sub c, s over the square root of n, less than mu, x bar plus z sub c, s over the square root of n. If it's a 99%, the z sub c is 2.58. Remember, if you forget that, you will have to go through the procedure. You will take your degree of confidence, divide by 2. So half of 99% is 0.495, which is 49.5%. Subtract that from 0.5. And that's the area that you look up in the 2-page Z table, or you do invert the norm. A negative 2.58, which by symmetry the positive is a 2.58. Hopefully you will not forget that, because you don't want to have to go through that procedure. But if you do, then you do know how to do that with the procedure. 2627 minus 2.58, 400 over the square root of 60. 2627 plus 2.58, 400 over the square root of 60. E is going to be the number we add and subtract. 2.58 times 400 divided by the square root of 60. $133.2306. 2627 minus 133.2306. 2627 plus 133.2306. Margin of error, 133.2306. That is the maximum difference allowed between the point estimate, x bar, sample mean, and the true mean. And we don't know the true mean, but it's the maximum difference allowed between them. Subtract from. That is 2493.7694. That's a 4. Add 2. $2760.2306, and we round to a whole number accurately because our sample mean is a whole number. 2494, 2760. There is the 99% confidence interval for the true mean weight of all automobiles, compact automobiles. Calculator. Stat. Test number 7. This is statistics. Now they did not give sigma, but they did give S of 400. X bar is 2627. Sample size is 60. C level is 0.99. And calculate. 24942760 exactly. If we use our trick for E here, it's not very helpful. That is calculator people. If you just witnessed, they gave exact lower and upper limit of 2494 lower, 2760 upper. So those of you relying heavily upon the 84 and you did not calculate E from formula and you're just using your final calculator answer, you're going to get a confidence interval width truly of 266, but when you divide by 2, you get an E of about a 133, but E is 133.2306. So this little trick for finding E is not that nice all of the time. And again, that's for those of you that do this, which is fine. And then your trick, find the confidence interval width based upon these two. And we have it rounded because there's no rounding. I'm using these exact values. And then find that difference and divide by 2. And it gives you 133 for your E. That's not going to be accurate enough, I'm afraid. I have every right on the test to give you a letter choice of 133.2306 and then a 133.0121. If you use the calculator trick, you may accidentally choose the wrong answer. The answer by hand is A, 133.2306. Again, I create the test as if I don't have a TI-84, I only have the table, and I only have the formula. So my formula for E is Z times S over the square root of N, 133.2306. And I use the rounding rules from the textbook. Problem number 2. For a group of 10 men subjected to a stress test, so N is 10, the mean heartbeats per minute was 126 for those 10 men. That's your sample mean X bar, and the sample standard deviation was 4. Find the 95% confidence interval for the true mean. So a group of 10 men, N is 10. Subjected to a stress test, the mean heartbeats per minute was 126. So that's X bar. And the sample standard deviation was 4. Sample standard deviation S is 4. Find the 95% confidence interval for the true mean. This is actually a T interval. It's a T interval. Sigma is unknown. That means they give S. And at the very same time, N is very small. It's less than 30. They take a sample of 10 men, and the sample standard deviation, they even say sample standard deviation, S is 4. So sigma is unknown because we know sample standard deviation, not sigma, and N is only 10. So check, check, both conditions are satisfied. The T sub C, we will have to go to column 95% degree of confidence and row degrees of freedom, 10 minus 1, 9. So go to row 9, column 95%. Your two fingers meet at a critical value of 2.262. Column 95%, row 9, 2.262. Next step is your formula, X bar minus T sub C, S over the square root of N. X bar plus T sub C, S over the square root of N. Those of you that mistakenly call it a Z interval, you'll probably use the wrong critical value of 1.96. The critical value is 2.262. 126 minus 2.262, 4 over the square root of 10. 126 plus 2.262, 4 over the square root of 10. E, 126 minus E, 126 plus E. That is going to be 2.262 times 4 over the square root of 10. 2.8612. 2.8612. Subtract from 126. 123.1388. Add to 126. 123.1388. 128.8612. Round accurately to the same places as the given sample mean, which is 126, and it's a whole number, 123, 129. Confidence interval width, 129 minus 123 is a difference of 6. Again, I'll ask you for this problem, the critical value is a separate question, the margin of error as a separate question, 2.8612, the final answer as a separate question, and the confidence interval width as a separate question. And that is a T interval for the mean problem. The next lecture is going to consist of proportion intervals for true population proportion. That's going to be section 7.3. Good news is with proportion intervals, we're still using the two-page z-table. So really there's not a lot of information there to share other than to show you how you actually find a sample proportion p-hat. And we will stay tuned and we will finish that and finish that in section 7.3, which would be a proportion z interval. So with this sheet completed, we have completed z interval for the mean and t interval for the mean. It is based upon the given conditions in the word problems, which you must pick out for you to decide, is it a z or is it a t? And it's so very important to be correct. If it's a z, use the z table. If it's a t, use the t table. If you don't know the difference, you're going to use the wrong table, use the calculator the wrong way, and receive the wrong answer. So practice, practice, practice. Read problems and just pick out the information that's given with key words. The word all and the word true always indicate a population. Practice and take care. I will see you next time with the third lecture, confidence intervals for true populations proportions. God bless you.